Hey students, this is Misty Witt. Today you're going to be working on math notes for solving proportions. You're going to go ahead and get your toolkit out, turn to page 8. You'll need a pencil and a highlighter. It looks like I'll just be using one color today, so. All right, we'll go ahead and get started. So let's start by reading what they have here. If a relationship is known to be proportional, ratios from the situation are equal. So if it's proportional, then the ratios are equal. An equation stating that two ratios are equal is called a proportion. There are examples there. So two ratios are equal is called a proportion. And they give you those two examples. So let's go ahead and note to ourselves, these are examples of a proportion. So we know that 6 miles per 2 hours is equal to 9 miles per 3 hours. And 5/7 is equal to 50/7. When setting up a proportion is one strategy for solving for an unknown part of one ratio. For example, if you have the ratios 9/2 and x/16 are equal, you could set up a proportion and solve for x. So they're going through a couple of different ways of how to solve proportions. So we're going to talk about a method called the giant one. We're going to talk about a method called undoing division. And then we're going to talk about a method called cross multiplication. All of these will work every time. Sometimes they're better options than other methods. So for the giant one, you would solve the proportion by using a giant one to find equivalent ratios. So what that means is since 16 is 2 times 8, you create the giant one shown at the right. So sometimes we call this finding a common denominator or finding a common, we could even find a common numerator in this case. This case they were talking about a common denominator because if the denominators are equal to 16, then the numerators have to be equal because there's an equal sign in the middle. So let's make a note of that over here on the side. So a giant one is just multiplying a ratio by 1 to change the way the ratio looks. And we want to change the way it looks because we're looking for some sort of same number on the top or same number on the bottom. So if we look at the example, I'm going to give you another example. So this example, let's say you have 3/5 is equal to 12/x. So I know that 3 is a factor of 12. And I know that if I multiplied 3 by 4, that would equal 12. So I can't just multiply the numerator by 4 though. I have to multiply the entire number by 4/4. Because anytime you multiply a number by 1, it stays the same. It's its identity. It's just going to look a little bit different. So if I were to take 4 times 3 is 12, and 4 times 5 is 20. So if your numerators are the same, and you have an equal sign in the middle, then your denominators have to be the same. So we could say that because 12/20 equals 12/x, then x has to equal 20. So this is a great method to use when you have one numerator or one denominator that is a factor of another numerator or another denominator. Let's take a look at the next method. The next method says undoing division. Another way to solve the proportion is to think of the ratio x/13 as x/16 is x divided by 16. Sometimes I tell my students all the time, anytime you see a fraction, think of it as a division problem. X over 16 is x divided by 16. So to solve for x, you would use the inverse operation of division, which is multiplication. Multiplying both sides of the proportion equation by 16 undoes the division. So because this person had x over 16, they would multiply both sides by 16 in order to solve that proportion. So let's take a look here. I'm going to give you another example. So when we undo division, works best when x, is being divided by a number value. If I had x in my denominator, this would not be the easiest method because you would multiply both sides by x and then you would have to divide out the other numbers. So this works best. Notice how x is in the numerator here and it's being divided by 16. It works best when that's the case. So let's take a look at another example so you have more than one example to reference. So let's say you have, for example, x divided by 5 equals 3 divided by 14, or x over 5 equals 3 over 14. So I see that x is being divided by 5. So in order to undo that division, I would like to multiply both sides by 5. So if I do it to one side, I have to do it to both sides. I got to keep it balanced. Now 5 divided by 5 is 1. And on the right side, I can write that out as 3 times 5 all over 14, which is 15 over 14. And you could leave it like that. It's an improper fraction, but it's still simplified. I can't simplify 15 and 14 by the same value. So that's just another example of undoing division. And we had our giant 1 up here so you can see